Right, let's have a look at temperature. And the first thing we need to know is that temperature is effectively a measure of the average kinetic energy of particles in a substance. And when we're talking about kinetic energy, we're talking really about the movement of particles. So a higher kinetic energy would lead to a higher temperature measurement. And also important to note, the word average is in there because actually in any given substance there will be a range of kinetic energy throughout my particles. Now what's important about this is that if I talk about temperature on the Kelvin scale, then the kinetic energy of the particles is directly proportional to that temperature. And this means I could draw a graph with kinetic energy on my x-axis and temperature in Kelvin on my y-axis and see a nice straight line representing a directly proportional relationship. And if I track that line back to the origin, I would find that if I have a substance where the average kinetic energy is 0, meaning that none of my particles are moving at all, the temperature would be 0 on the Kelvin scale. In fact, we call that absolute 0. So that relationship is going to be super helpful for us to determine something about the kinetic energy of the particles in the substance. Let's take this one step further. Let's look at two thermometers. The one on the left has units of degrees centigrade, and on the right we have units of Kelvin. And the first question you might ask is, why do we more commonly in a lab measure things in degrees centigrade? Well, it's a very common unit of temperature, and it's set with numbers at certain points because they actually relate to properties of water. So 0 on the degrees Celsius scale is the freezing point, 100 is the boiling point, and those are kind of temperatures that we come across in everyday life. Importantly for IB chemistry, you'll notice the relationship between the degrees centigrade scale and the degrees Kelvin scale. So if I want to actually calculate the temperature in Kelvin, I need to take the temperature in degrees, as you can see in the formula at the top, and add 273. And you can see that clearly on the diagram, where if I go from 0 degrees centigrade, that is the equivalent of 273 Kelvin, and for 100 degrees centigrade, it's 373 Kelvin. So let's zoom in a little bit on those thermometers to identify another key point here. Here's two thermometers in the same substance. You'll see in degrees it's got a measurement of 1, and in Kelvin it's got a measurement of 274. Now if I were to heat my substance slightly and watch the temperatures go up on the thermometer, you'll notice they've gone up by the same amount, and if I look at the actual gaps between the numbers, on the left thermometer, the degrees centigrade, it's increased by 1 degree centigrade, and on the right thermometer it's increased by 1 Kelvin. So because the gaps between centigrade measurements and Kelvin measurements are equivalent, we can say that a change in temperature in Kelvin is going to be exactly the same as the change in temperature in degrees Celsius. So if one number goes up by 10, the other number will go up by 10. So there's a subtle difference. On the right hand side of this page we're talking about change in temperature. On the left hand side we're talking about a single temperature measurement. And that's pretty much it for temperature. Hopefully this video is of some help.